So about the cut point or cutoff value C, so the different choice of C gives different tests and different reaction reasons. So the smaller C gives a smaller type 1 error, the larger C gives a smaller type 2 error. And we can create a size alpha test by choosing appropriate C. So we choose appropriate T such that the supremum probability that lambda x less than equal to C under the null hypothesis is alpha. I mean, which is the definition of the size alpha test. So we can modify this C, then we can create the size alpha test. And let's look at the example. So we are consider testing theta is less than or equal to theta 0 as the null, and theta is greater than theta 0 as alternative, and we would like to find LRT and its power function. And we have a normal random sample. Then likelihood ratio is and then for denominator, we already know that the sum of the xi minus theta square is minimized when theta equals x bar, and then which maximizes its likelihood. So the maximum likelihood statistic for denominator is that the statistic that minimizes the sum of the xi minus theta square. And we already studied that the sum of the xi minus theta square is minimized when theta is equal to x bar. Then the problem is the numerator. So we have restriction is the theta is less than or equal to theta 0. And then we can think of the two cases, when the x bar is less than or equal to theta 0 and x bar is greater than theta 0. So if you look at the graph, here, we already studied this before. So when the this is x theta square minus the sum of the 2 times xi plus the sum of the xi squared. If you expand that, you get this one. Then we can see that if theta 0 is less than x bar, I mean this is the case. So in this case, the x bar is the because it's a decreasing function and until the x bar, so it's gonna and then it's increasing after the x bar. So if theta is 0 is less than or equal to x bar, then this is the x bar is the minimizer. However, if theta is the x bar is greater than theta 0, if you have a this case, then so we can see that x bar is greater than theta 0, so that the since we are maximizing theta greater equal to theta 0, so the theta 0 is the minimizer. So we can have this one. So we can see that, so we can calculate this likelihood ratio. So this likelihood ratio, when x bar is less than or equal to theta 0, then we have a same minimizer on x, and for x bar on here, so we plug in the same we plug in the same value, so we get a 1 on here. So if I run this again, that makes so we have the same minimizer in here. So that's why we get the 1. When x bar is less than or equal to theta 0. And x bar is greater than theta 0, then we can get you can get this ratio, which is equal to which is the exponential of minus n times x bar minus theta 0 squared divided by 2 sigma squared. You can calculate this one. I will leave this one as an exercise. So we have these two cases, and then so we reject H0 if and only if we have this likelihood ratio statistic and x bar is greater than theta 0, because there is no meaning to test when lambda x equal to 1, because we always do not reject H0. So we reject H0 if and only if expectation exponential of n time minus n times x bar minus theta 0 squared divided by 2 sigma squared is less than or equal to c, which means that which is the formula is equivalent to say as the absolute value of x bar minus theta 0 greater or equal to square root of 2 sigma square log of c divided by n. And then we reject H0 if and only if x bar minus theta 0 is greater or equal to square root of 2 sigma square times log of c divided by n. So we can simply remove the absolute sign because we have condition that x bar is greater than theta 0. Which is the equivalent to say that x bar minus theta 0 divided by sigma divided by square root of n is greater or equal to square root of minus 2 times log of c, and then we define right hand side as c star. Then the power function So we can obtain the power function as the p theta is the x bar minus theta divided by sigma divided by square root n square root c star, and then we can subtract and add the theta, and then we can get the x bar minus theta divided by sigma square root divided by square root of n greater or equal to theta 0 minus theta divided by sigma divided by square root n plus c star, and that probability is that's the power function. And since we have normal distribution, so this standardization is the standard normal. So our function is given as this. And then now we would like to construct the size alpha test. Then we would like to choose such that the choose so we choose the supremum theta is greater than equal to theta 0, the probability that reject H0 is the alpha. So we would like to know that probability that z is greater or equal to theta 0 minus theta divided by sigma divided by square root n plus c star, the supremum under the condition that theta is less than equal to theta 0 is equal to alpha. So theta 0 minus theta divided by sigma divided by square root n is decreasing function of theta. So the probability that z is greater or equal to theta 0 minus theta divided by sigma divided by square root n plus c star is increasing function of theta. Because this ratio is when this ratio decreases, this probability increases, because the probability is we are considering z is greater or equal to the ratio plus z star. So when this ratio decreases, then the probability increases. Hence this probability attains its supremum or maximum when theta is equal to theta 0. So which is the supremum achieved at the theta equal to theta 0, so which gives the probability that z is greater equal to c star. And we choose c star equals z alpha, where z alpha denotes point such that probability that z is greater than z alpha is equal to alpha. So when you have normal distribution, this point is z alpha, where the area under the curve after z alpha is alpha, which is probability that z is greater than z alpha, where z is 0, 1. So when we have a standard normal distribution curve, and then we know that the area under curve after this z with this subscript alpha is equal to alpha. So the z alpha is the point that satisfies its probability z is greater than z alpha is the alpha.